Right, good evening. Sorry. Let's start. Unit number 15 we are starting up, that is hydrostatic pressure. Hydrostatic pressure. Okay. Hope everyone got the dudes. Yes, could you please take them? Take the dudes, please. Right. So it is a physics chapter, one of the easy chapters. Okay, one of the easy chapters, and probably will be coming for the third term exams as well. Okay, easy theories are there. Are some practical examples also how to learn in this chapter. Okay, so along with the two, we are going to summarize the lesson step by step. Okay, mainly we are dividing this lesson into two. Listen, everyone, we have started. First part we're gonna speak about the pressure exerted by solids. The pressure exerted by solids, liquids, and gases. Okay, and gases onwards. Related to these liquids and gases, what are the applications? What are the examples? If any laws and principles are there, these are what we are going to learn. These are the two divisions made. Okay, so look at the first part. Pressure exerted by solids. Pressure exerted by solids. So what is this pressure exerted by solids? Pressure exerted by solids. Look at this now. This, excuse me. So, look here. Pressure exerted by solids. This refers to when you're going to take an object, and over this object you are going to apply a force. You are going to apply a force. So let's say this is the surface. Okay. Over this object, you do have another object kept vertically, and you are going to apply a force here. You are applying a force here, right? And this is the surface where the force is exactly applied on. This is a surface. On this surface only you are applying the force. Okay. So what is called pressure? Pressure is the force acting over a unit area. It may be any amount of areas. Maybe any amount of areas. We're gonna find out what is the force acting on 1 unit area. What is the force acting on 1 unit area? In 1 area. Okay. 1 unit area refers to 1 square meter. 1 square meters. In 1 square meter, 1 meter square area, what is the force acting? That is called pressure. That is called pressure. So how do we take that? For example, let's say same like another object I'm taking. This is the object. Okay, this is the object, the second surface. Over this object, you're gonna have another surface there. It's having a surface area like this. This is the surface area. Okay. So total area, surface area, and you are taking surface area is the contacting area. Contacting area. So now you see through this point only you are applying a force here, and this is the surface area. Okay. And this is the force you are applying. There's a force you are applying. How to find out the pressure? The pressure is equal to perpendicular force we take. What force it is? Perpendicular force, because it should be at a 90-degree angle. Okay, should be exactly at 90-degree angle. 90-degree angle, what is the force acting? That is the perpendicular force. This perpendicular force you have to divide by the surface area. Surface area. Okay. So pressure is equal to perpendicular force divided by the surface area. So pressure is indicated by P. Force is F dividing by A. Dividing by A. P is equal to F over A. P is equal to F over A. Very simple formula here. P equals F over A, where the force is measured by Newton. Force you have to measure by Newton. What is this force? The force you are applying on. The force you are applying on. Surface area is measured by square meters. That means the surface exactly where the force is acting. Now imagine over this, okay, over this duster, you are going to apply the force by this marker. It's acting on, right? So the force you are applying, pushing it, that is the perpendicular force. Now this is the surface contacting on, right? This is the surface contacting on. So the surface area contacting will be equal in both the sides. So if you are contacting through this over the board here, same force will be same surface area will be there here as well. So this is the surface area already. So you see, surface area is measured in square meters, force is measured in Newton. If any other unit given, you have to convert it. You have to convert it. Now, accordingly, how do you find out the pressure here? You see, m square when you take up, it becomes nm minus 2, right? Now, m2 when you take up, m square when you are taking up, each point important here, please listen. So, m square when you take up, it becomes m minus 2, m minus 2. So, this nm minus 2, how do we read this? Newton per square meters. How do we read that? Newton per square meter. So, this Newtons per square meter is, okay, Newtons per square meter, okay. So, this is the fundamental unit of pressure. It is the fundamental basic unit of pressure. But we are making it equal to Pascal, PA. Pascal, it is the standard unit of pressure. It is the standard unit of pressure. So you see, two questions may be there. One, what is the fundamental unit of pressure? Fundamental unit comes from these two, Nm minus 2. What is the SI unit, standard international unit? That is PA, Pascal. The Pascal word is given because of, Blaise Pascal. He was a person, he was a scientist who was contributing towards these pressure related theories. So as a honor, we are using the word Pascal here, and that is the SI unit. Is that clear? So P is equal to F over A. And if you ask me, is it always vertical? No. It may be vertical, horizontal, anyhow, what is the force acting over a unit area? This is called pressure. Is that clear? So we're gonna take here, this is the surface area, and even here, this is the surface area. Surface area, the area which is contracting on. Now imagine sometimes, let's say a sort of a ball pin. A ball pin you are going to push it over a rigid foam or a wood board or something else. Now you are going to keep your fingers over there, right? The thumb, you are going to, we say thumb stop. Okay? So you are going to push it over. So this is the surface being contacted. This is the surface being contacted. Okay? Now I'm standing. When I'm standing, my weight is there over the floor. So my weight gives a pressure to the floor. Where is it giving? Through my feet. So my feet does have a surface area at both the feet. So this is the contacting surface area over the floor. Is that clear? So when you are lying down, now the surface area is high. The surface contact, but the weight won't be changing height. Same weight. You understand that? When you are standing, what was the weight? The same weight will be there when you are lying down, when you are sleeping down. Okay? When you lie down, weight is same, but the surface area is different. So when these factors are changing, okay, the parallel factor also will be changing. That relationship is what next we have to build on. So we'll write this down first. Write down the view on the first dotted line. The force acting over a unit area, the force acting over a unit area, acting over a unit area is called pressure. The force acting over a unit area is called pressure. The force acting over a unit area is called pressure. Okay. And write it down inside the text box there. Yeah, when you draw it. Draw it to the left side and mark it as F and A. And force over area is pressure. Then Fine. Now we see. Look at this. Look at. We are going to rearrange this formula. Guys, look at this. We're gonna rearrange the formula. What is the formula now? Tell me the formula. P is equal to F over A, right? P is equal to F over A. Actually, what is shown here, this is the equation triangle, formula triangle. So the formula triangle we are basically using for 3 factors formula. Basically for 3 factors formula. Now how do we apply them? Okay. This is not a theoretical part, but if you can apply this, any formulas you can tackle easy. Okay. So easy. F is equal to P into A, right? So I'm going to take F here. Okay. Then F is equal to what you want to find out. Okay. You have to see what type of product it is. It is in the form of A equals B into C. Into is there product you have to take here. Okay. And A is there. Who is alone? Alone you have to take out. So F is equal to P into A. Correct? Okay. F is equal to P into A. Actually, it came because of P was equal to F over A, right? F over A. Now, how do you directly apply this? F over means it's division. This line refers to division. Okay. So can you see? If I gonna take, yeah, P is equal to F over A, right? So P is there here. You close this P. What is remaining? F over A. Can you see that? So I have applied F is equal to P into A. Why? Because when you take this A here, F is equal to P into A. When you are subjecting in this form, when you are subjecting in the form of A equals B into C, F is equal to P into A. So now when you are using this formula in this way, can you see? You want to find out P, so you are calling P. Now what is the remaining? F over A. So P is equal to F over A, correct? Like the same now, let's say you want to find out F. If you count, who is there? P into A. That's correct, right? F is equal to P into A. And you want to find out A. A is equal to F division P. F over P. F over P. So likewise, you can rearrange the formulas depending on the question. Can you see? Right. Now, related to this formula, there are some relationships that we have to build. Some relationships are there we have to build. Okay. First letter. Yeah, then the first letter is what we took in. P and force area A. Yeah. That is what we are taking as a symbol also. Right, look at this now. Look at this. Now, these theories are not there on your tube. That's an additional part. Now, look here. What is the formula ultimately we are using? P is equal to F over A. This is the formula we are using up, right? This is the formula. I'm going to build up some relationships. What is the relationship? Look at this. I'm going to use if A is constant. Who is constant? A is constant. The box bracket shows you it is a constant. You are having a surface area, same surface area. Same two surfaces you do have, and you are going to change the force you are applying. What is the relationship here? The relationship shows you if area is constant. P and F, when you see these two, either side of the equal mark, you can see both of them are above the line. Above the line means both of them are numerators. Okay. So as both of them are numerators above the line here, P is directly proportional to F. P is directly proportional to F. So how did we take that? P is equal to F over A. A is constant. Constant means not changing to the same surface you are going to compare. P and F, both of them are either side, both side of the equal mark, and both of them are numerators. This is the condition. Then they are directly proportional. Directly proportional means when one quantity is increasing, the other one will be also increased. When one quantity is decreasing, the other one will be also decreased. That is a direct proportion. So what is the meaning of that? Here, if you increase the force, pressure will increase. If you decrease the force, pressure will decrease. Is that clear? Clear? So what is the proportion here? P is directly proportional to A. The question asks you what is the relationship of pressure with force. If the area is constant, these two are directly proportional. Is that clear? Clear about that? Directly proportional. How do you say that? Let's see. I'm going to take an example like Area is constant, right? I'm having two objects. I'm having two objects having the same area. Area is A. Same area. Same area. And here you're going to apply the force F1, and here the force is F2. Okay. Let's say F1 is equal to F. F2 is equal to 2F. What is the meaning of that? F1 is equal to F. F2 is equal to 2F means force is more, right? Force is double up, right? Do you understand that? In my example, I have taken here the force given at the first. This is the first image, okay, and the second image. In the first one, it is F. Second one, it is 2F. That means increase. So according to this, can you tell me whose pressure is more? Is it the first one or the second one? The pressure is more. Second one pressure is more, right? How to take that? Since F1 and F2 you compare, F2 is more, right? So the pressure at 1 should be less than pressure at 2. Pressure should be more in second one. Did you understand that? So force increases, pressure increases. Force increases, pressure increases. To decrease the force, pressure decreases. Condition A must be constant. A must be constant for the same sum. You understand that? Right. So same way, let me take another example. What is the other example? Now I'm going to take what if force is constant. That means you have the same force. Earlier you took same surface, right? Now you are going to take the same force in two different surfaces. Two different surfaces. Now force is constant. So this person is constant. Now who are there? P and A. P and A when you are taking either side of the equal mark, right? And are they in the same numerator? Oh, one is numerator, the other one is denominator. Up and down, right? Can you see P is numerator, A is below the denominator. If up and down cases are there, you are taking them as inverse proportion. What proportion are they? Inverse proportion. So here I can take P is inversely proportional to A. P is inversely proportional to A. Okay? Directly proportional to 1 over A. The symbol is direct proportion 1 over A. 1 over A means inverse proportion. What is the meaning of that? Keeping the force same, you increase the surface area, pressure decreases. Decrease the surface area, pressure increases. Clear? Inverse proportion refers to one quantity you increase, the other one decreases. So area you increase, pressure decrease. Area you decrease, pressure increase. Okay, what is the example? Let me take. This is the first surface. Okay, A1, and another surface I'm going to take. It is A2, right? A2. Now you can see the surfaces have been different, right? You're going to apply the same force now. You are applying F. You are applying F. Okay, applying. The actual thing is here only the surface where you are applying the force I am giving. Okay, so this is kept on another surface, something like this. This is the surface where you are giving the force. Okay, so the second surface may be large or small. That's a different story, right? So here we see now the surface has been increased, right? You want to check it out with the pressure. You can see A1 and A2 you take. A2 is more, right? A2 is more. Now we learn if the surface area is high, pressure should be less. Then tell me whose pressure is less here? Is it P1 or P2? P1 or P2, pressure is less. P2, right? Why? A increases means P should be decreased. Surface area high means pressure should be less. Correct? Pressure should be less. Did you understand that? Surface area high means pressure should be less. So, area is increasing. Pressure should be decreasing. Pressure should be decreased. Did you understand that? So, area is increasing, pressure is decreasing. Pressure is decreasing. That is the idea. Clear about that? Clear? Okay. So, accordingly, you see, this is what the relationship between these two factors when you come to P equals F over A. Clear that part? Clear? Could you please take the writing book? Don't copy this. Okay? Note of dates. You have to take the note from here. Put the topic hydrostatic pressure. Quickly write it down. Hurry up, hurry up. Take it. If pressure is constant here, the other two factors you are taking as relative proportional, say there is an issue. Okay? You can build up the formulas that. Yes. Unit 15 hydrostatic pressure. Alright, please do it quickly. No, only this. Hurry up, please. Hurry up. Hurry up. Okay. Do it quickly. Do it quickly. Write it down. I was trying to very good. Just write it down. Hydrostatic pressure. Partner, do it, please. Rahim. Yeah, partner, do it. That I don't know. Surface area. Next, here, same surface area, goes to the next. Then you can increase the height or increase the surface area. I'll come to it. Increase the surface area, furthermore, pressure will be reduced. Done? Hurry up. Hurry up. Next one. Right. So, some examples are given. Can you see? Okay. Where do we use these applications? Look here. Now, you can look at your view. Some of the applications are there where we use this pressure. Okay. When you come for the shoes with heels and shoes without heels on your leg. Okay. So if you are going to get a shot from these shoes with heels and without heels, it will be painful. Experience. With heels or without heels, it will be straight. Right? With heels. With heels. Why is that? Why? It is because look at this. With heels when you are taking guys. Okay, listen. With heels when you are taking, surface area is less, right? Surface area is less. Without heels, surface area is going to be higher. We need the shoe. Okay. So giving the same force, you can see if the force is same, if the force is same, surface area and pressure are inversely proportional. If the higher surface area is given, pressure will be less. So with heels, surface area is less, pressure will be high. Without heels, surface area is high, pressure will be less. You understand that? Okay, if someone is hitting you, just check it if the heels, if the shoes are with heels or without. Okay. Leather shoe means it's still the same. Surface area is same. Surface area is same. If the same surface area, same force given, then pressure will be same. Pressure will be same. Is that clear? Okay. Surface area is what matters here. Right. That's one example. And also, look at the tube. You have to read the tube. Second example goes up with. Now, imagine you will have a sandy area, sand containing area, okay, or a clay area. Like when you lie down on the sand, okay, you are less likely to be sink down. You want to be sinking down. Okay, you want to be sinking down. Why is that? You are not sinking down here because you are having a larger surface area. You are having a larger surface area. Something like, so you are lying down. So it's a larger surface area. Larger surface area. Okay. So surface area high means pressure acting will be less. You are having the same weight, right? Even you are lying down or sitting down, even you are standing, weight won't be changing, right? Weight won't be changing. So same weight, larger surface area. Surface area high means pressure will be less. So you won't be sinking down. But when you're gonna stand like this, okay? When you're gonna stand, these are the two surfaces being contacted, right? The feet. So surface area is very less. You can see surface area has been decreased. When the surface area is less, pressure will be increased. Pressure will be increased to the same weight. Weight is same. Surface area reduced means pressure will be high. Pressure will be high. Do you understand that? That is why you will be. Doesn't get up. Get up. Fast get up. Get up. Can you both explain me this? Get up. Pressure decreases. Whose pressure? You are learning in English medium. I am teaching in English. Yes. Standing. Explain me this example. This example. Others keep quiet. Surface area is different. Whose surface area is high? Whose surface area is high? When you are standing, surface area is less. Surface area is less. When you are lying down, surface area is more. The surface area, pressure will be less. Surface area less means pressure will be high. Is that clear? Okay. So down. Right. So that is one example. And another. I told you, can you remember the ball pin? Okay. The ball pin will be having just like an umbrella structure where you do have such a small edge. Here you are going to apply the force. Okay. And the force will be acting over this paper or artboard or even a regiform or whatever. The whole force you are giving will be acting over this surface, right? Can you see? Right. Now surface area is very less. Surface area less means pressure will be very high. So what happens? It's easy for the pin to go down, penetrating the board. Is that clear? That is why usually these like objects, they do have a thin edge. Needle having a thin edge. nail having a thin edge. Okay, knives, blades, cutters, scissors, all of them are having a thin edges. Why? You give a force. For the force you give, surface area since it is very small, contacting area since it is very small, pressure will be very high. Pressure will be very high. So as the pressure is high, you can do the work very easier. You can do the work very easier. Is that clear? Right. It is also the same. Bullets are also the same. Why? They don't have a flat surface, right? If it is a flat surface, it's hard for them. Even the nail you take, nails usually they don't have a flat surface. Screw nail is a different story because that is not penetrating down, it is screwing down. You are rotating, right? Screw nail when you are taking, you have to rotate. And still, some of the screw nails are there pointed edge, but some of them are flat. And that is how they are designed with the key lock positions. Okay. So here, basically they do have these clean, thin edges to make the surface area less so that the pressure will be high. Pressure will be high. Is that clear? Okay. Right. And furthermore, now vehicle jacks are there. Now you could have seen when you drive on the street, sometimes you can see some vehicles have been stopped and they have been lifted up in an angle, slanted. Okay, maybe because of a repair. Just imagine, tons of kilograms sometimes will be there, or thousands of kilograms will be there in small vehicles. Okay. Is it easy for one or two people to easier lift it up? No. And there is a small object, a vehicle jack we say. Okay, hydraulic jack is a word. So what we do there, it is a smaller surface that is being kept over there down and slowly you have to push a small handle down. Then it will be lifted up. What's happening here is a concept is different. Concept will be taken separately. Here, you see it's a smaller surface area. Smaller surface area. When you're gonna keep it over the street, over the road, and when you are going to apply the force to lift up the vehicle, okay, surface area is very less weight, so the pressure will be very high because of the weight of the car or the van or whatever. So a higher pressure will be exerted on the road, on the street. If it is a sand-like structure, definitely the vehicle jump goes down, so you can't lift up the vehicle. Or if it is any other structured road, because of the high pressure given, that the area may be getting damaged. So that you would have seen when you are using the vehicle jack, below the vehicle jack, there is a wooden like plan, or as a steel like structure, a box structure is there. That means, imagine this is the vehicle jacks, okay, and we'll be having a structure in this way. Why? In order to increase the surface. Or else separately we are giving another wooden plank down to increase the surface area where the force is acting. So when you increase the surface area, you can reduce the pressure. You can reduce the pressure. You understand? So this is also an application. Moreover, your school bags are there. When you come for your bags, you do have a broader strap, right? Imagine 10 books you have, 10 textbooks or 10 writing books or whatever you are putting over your bag. Okay. Now the bag when you are holding up with your broader strap, you are having a pressure over your the shoulders, right? Right. Now the same set of books you're gonna apply for another bag having narrow straps. The straps are narrow. Okay. Now when you carry that in the same like bag, okay, what will you feel for the pain? Will it be increased or decreased? Will be increased, right? Why? Just imagine some boy, some boys they used to have bags having small, rope-like structures, basically. Okay. So rope bags are there, rope straps are there. Okay. So these bags when they are carrying on, they will be having a high pressure actually. I'll come to the point, wait. Okay. With the same set of textbooks. But most of the time, why are they using that bag? Not to take the textbook to school, right? Nothing will be there inside, only the bag. So then you won't be having any weight, any pressure. I'm telling, same 10 textbooks if you're going to apply over there. Only the broad and the narrower straps are different. Broader strap having a high surface area will be giving a less pressure over your shoulders. Okay. For the same weight, if you are applying narrower straps, surface area less means pressure acting over your shoulders will be high. Did you understand that? Is that clear? So accordingly, you see that is also an example where we use this high pressure, low pressure. Okay. And more. You could have seen the vehicles, the long vehicles, the huge vehicles when we are taking, they will be having number of wheels more, tires are more. Okay. Some 8-10 tires are there. Why? Surface area increase because tires are contacting over the street. Tires are contacting over the roads. Okay. So more the tires, surface area will be high. If the surface area is high, the loaded up the goods, giving the force over a larger surface area high means pressure you can reduce. Otherwise, having less number of vehicle tires for long vehicles when you are running on, having a smaller surface area, pressure will be high, the roads will be quickly damaged. So that they do have large number of tires. Is that clear? Clear about that? So these are some examples where we use this pressure concept. Clear? Some questions will be there. They will ask you, if you want to increase the pressure, keeping the same force, what are you supposed to do? You have to decrease the surface area. You understand my point? Keeping the same force, you want to increase the pressure means you have to decrease the surface area. Keeping the same force, you want to decrease the pressure means you have to increase the surface area. Keeping the same surface area to increase the pressure, increase the force. To decrease the pressure, decrease the force. This is how the questions come in MCQs. Clear about that? Clear the theory? Right. Now, related to them, some questions are there. Okay. Some questions are there. You can see. Those questions are taken next in your two. 3 questions are there. Okay. Could you please find out the answers for them quickly? Give me the answers quickly. Hurry up, please. 5 to do it. Okay. Not to shout, quietly do it. Look at this. What is the question? Look at this. What's the question now? See? Look at this. A force of 500 Newton acts on an area of 0.02 square meters. Find the pressure that acts on the surface. How do you find out? Pressure equal force over area. Force over area. How much is the force? 500 Newton dividing by 0.02 square meters. Now, when you are writing, it's must for you to write the formula. Some big-headed people are there and they never write. Same thing they do with the exams also. Where the marks go after that coming up, no marks. Don't be. Follow the steps. Write the formula. Some they write the formula. So we don't want the next step. We will straight away write the answer. Never mind, wait. You won't get marks. Clear? Follow the instructions. Step is must. You have to write your answers, find out the calculation within 3 steps. First the formula, second substitution, third one answer. So 500 divided by 0.2. In between any other steps, if you are writing, you won't get marks. Okay, you won't get marks. Only for 3 steps, probably you are getting marks. But if it is needed for you, you can write. Okay, something like 500 divided by 0.02 square meters. Now the problem is with this 0.02, it's hard for you to simplify. What do you do? I told you to shift it, skip that. How to skip? 2 zeros, you have to multiply it. Okay, let me write it separately here. Means 0.02 if you multiply by 100, 2 zeros, you can skip this, right? Okay, you can shift those decimals, correct? Why did I choose 100? Because there are 2 decimals. If it was only 1 decimal, 0.2, then I have to multiply by 10. If it was 0.002, 3 decimals, I have to multiply by 1000, 3 zeros. Now, can I do that only for the denominator? No, because it's a group. For the numerator also I have to do the same. That means 500 also I have to multiply by 100. I told you to do the same thing for up and down. Some of them they haven't done that. They have taken only this as 2. It can't be done. Equally hard. In an equation, when you are additionally doing something, you can't do for only one person. Whomsoever is there, for everyone you have to do that. So, now how much is it? 500 with 2 more zeros, it's 50,000. Dividing by, it's 2 now. Correct? 50,000 over 2, how much is it? 25,000. Okay. So what's the answer here? 25,000 Newton per square meter. Right? Can you remember? M square will take up in minus 2. I told you instead of this Newton per square meter, whom you can write? 25,000 pascals you can write. Is it must to write this? No need. Straight away you can write 25,000 pascals. Clear? Please correct it. Who did get this correct? Correctly done. Fine. Correctly done. Right? Fine. So, others, please correct your answer. Correct your answer. And partly do it, okay? Right. Go to the next question now. What is the second question? Have a look. Yeah. What are you doing? What is the second question? Can you see? Now you are going to keep an object of 30 kilograms. Object of 30 kilograms on an area of 0.02 square meters. So 0.02 is the square meter and the weight is not given, the force is not given. You are going to give an object of 30 kilograms. 30 kilograms, you can convert it into newtons. How do you convert? 1 kilogram is equal to 1 kilogram is equal to 10 newton. Okay, that comes because of the gravity. Gravity is 10 if you are taking. If the gravity is given as 9.8, or take it as 9.8 newton. Okay, 9.8 because of the multiplication that comes in 4th chapter. Can you remember? W equals m into g. Weight is equal to mass into gravity. Mass, if it is 1 kilogram, gravity is 10. 1 into 10, 10 newton. Mass 1 kilogram, gravity if you are taking as 9.8. 1 into 9.8, 9.8 newton should be there. So, as I told you, easy calculations, usually they will be given 10. So, you can write it accordingly. So, now, how do I write that? 1 kilogram equals 10 newton, 30 kilograms I am having. So, I am writing 30 into 10 newton. You understand? 1 kilogram is 10 Newton. 2 kilograms, 2 into 10. 3 kilograms, 3 into 10. 30 kilograms, 30 into 10. 30 kilograms, 30 into 10. So I took it as 30 into 10. Dividing by 0.02 square meters. Okay. Now, same thing gonna happen, right? 30 into 10 means 300. So this 300 also have to multiply by 100 because here also 0.02. So this 0.02 also have to multiply by 100. Then how much would it come? It comes 30,000 divided by 2. Correct? Am I correct? Is that clear? 30 into 10 by to convert the grams into to convert the kilograms into Newton. 30 into 10 kilograms to Newton. Okay. So 300 must be multiplied by 100 dividing by 0.02 into 100. Okay. So then 30,000 over 2. 30,000 over 2. How much is the answer? 15,000 pascals. Capital P, simple A. 15,000 pascals. Okay. Right. Next question. The next question there. What does it ask you? The mass of a man is 70 kg in his standing position. His feet covers an area of 100 square centimeters. What is the pressure on the ground due to his weight? What is the answer you got? 7 pascals. 70. 7,000. Right. Listen. Okay. Now the problem is conversion. The mistake here is conversion. Okay. Look here. Now you see, 1 meter is equal to 100 centimeters cube. 1 meter is equal to 100 centimeters cube. What is this given in square centimeters? Right? This square centimeters you have to convert into square meters. Meter square you have to convert it. Okay. Now look at this. What you have done was this 100 you have divided by 100 to make it meters, which is wrong. Why wrong? Centimeter to meter, okay. 1 to 100. Square it is not the same way. How it comes? Look at this. Look at this. 1 meter is equal to 100 centimeters. Then 1 meter square is equal to 1 meter into 1 meter, right? Am I correct? Abdrahim, 1 meter into 1 meter. So 1 meter is 100 centimeters into another 1 meter, 100 centimeters. So 100 into 100, 10,000. So 1 meter square is equal to 10,000 centimeters square. Then how do you convert meter square into centimeter square? Multiplying by 10,000. How do you convert centimeter square into meter square? Division 10,000. Division 10,000. So this is the concept you have to use here. Okay, now look at this. This 10,000, how do we write it as a, as a power? How do we write? Into 10 to the power 4, right? 4 zeros, 10 to the power 4. So instead of into 10,000, you can write into 10 to the power 4. Division 10 to the power 4, how do we write? Into, since it is division, when you take it up, it becomes minus 10. Correct? So the division you can write it as multiplication 10 to the power minus. Minus. Is that clear? So now look at the question. You want to find out the pressure. Pressure equal force over area. How much is the force? 70 kilograms. 70 into 10 Newton. 700 Newton. Dividing by. You have to show that. Okay. You can't just straight away. You have to methods. Sales are important. Area. Surface area. Surface area is equal 100 square centimeters. How to convert square centimeters into square meters? 100 divided by 10,000. Okay, 100 divided by 10,000. That division 10,000, how can I write there? As 10 to the power minus 4. So I can write it as multiplication 10 to the power minus 4. Now it is converted into square meters. Is that clear? Don't just copy. Understand the concept. Okay. 100. Real thing is this 100 you have to divide by 10 to the power 4. Okay. When you divide it, it becomes into minus 10 to the power 4. Into 10 to the power minus 10 to the power minus 4. So now we simplify. How will it go? These two zeros you can cut, right? Then it is 7. Okay. 7. 10 to the power minus 2 when you take up becomes 10 to the power plus 2. When you are taking up and down changing, plus minus change, right? Right. Now Newton meter square when you take becomes m minus 2. 7 into 10 to the power 4 means 4 zeros. 70,000 pascals. Not 7,000. 70,000 pascals. 70,000 pascals. Is that clear? Again, final answer 70,000 pascals. Please write them down. Show all the steps here. Show all the steps. And guys, look at this. Separate it by a line and write this down on the tube itself. Separate it by a line and write. And I want you to write in an order. Okay. Here, I want you to write it in order. Write them in one line. Okay. So I'm showing you the method to write. Same thing you have to apply on your exams. Don't write here and there. Align them. Either vertically or horizontal, align them in one. What is this name? Where's the answer? Where? What is this? What are you doing there? Now here, I have decided not to give the tools from the next chapter. Yes. It's useless. Okay. It's useless. I told you. I'm giving this free. Okay. Yes. Okay. So I thought of not to give the tunes from next lesson. Okay. The whole tune I want give. I will send you the PDF. No, it's up to you. Now I can see now the way you are using the tunes and all. It's useless of giving the tunes. Okay. So what I do, I'll send you the PDF. You get the prints. It's up to you. You get the prints. Then it will be having a value, right? Okay. When you are getting it free, you don't have a value. You pay, you get the print, and you come up with the tune. I will give a short note as a printed form where we will be writing question and answers. That's easy. Okay, now we'll do like that. We'll do like that from the next class. Next chapter we'll be doing like that. Okay. No, you get the prints. I'll send the PDF earlier. You get the prints and no, we'll do like that. What? So how much I'm saying? Use it properly, right? Cutting, talking, just like it is there inside. Done? Hurry up, hurry up. So we come to the next one, hydrostatic pressure. Now solid pressure is there. What is the topic to learn now? What is the pressure? Solid pressure. Tell me, how do you find out the solid pressure? How do you find out the solid pressure? Pressure equal force over surface area. You have to completely tell it as perpendicular force over surface area. Perpendicular force over surface area. Perpendicular force is measured by Newton. Surface area is measured by square meters. Square meters. So P is equal to F over A. Right. Hydrostatic pressure. Hydrostatic pressure refers to the pressure exerted by a liquid column. Pressure exerted by a liquid column. Okay, so let's write the next one. Let's write the next one. Okay. The pressure exerted by the pressure exerted by cut the word by. I'll make it short. The pressure exerted at the pressure exerted at a certain point. At a certain point, the pressure exerted at a certain point in a liquid by the liquid column above it. In a liquid by the liquid column above it. Liquid column above it. By the liquid column above it. Okay. Yes. The liquid column above it. So the pressure exerted by liquids. Guys, listen. The pressure exerted by liquid. Okay. We just wrote the definition. Okay. The pressure exerted by a liquid is called. Now, when you're gonna take a liquid column in this way, let's say I'm having a liquid column like this. Okay. I do have a tube. In the test tube, you have water here. You have water. Okay. And this is the height of the liquid column. This is the height of the liquid column. Okay. And you're gonna apply, you're gonna find out the pressure exerted by this liquid column at the bottom. You want to find out the pressure. Okay. In finding out the pressure here, we need three factors. What are the three factors we need? What are the three factors? One is the height of the liquid column. One is the height of the liquid column. That means if you change the height, pressure will be changed. Okay. And the other one is the density. What is the symbol? We term it as rho. Rho. Okay, we term it as rho. Rho is the word. Rho is the name of the symbol that refers to density. Density. What's it? Density. Rho. So one is the height of the liquid column. The other one is the density of the liquid. And the other one is G down gravity. So these are the three factors affecting the pressure exerted by a liquid column. Pressure exerted by a liquid column. So how do we find it out? We find it out in this way. Liquid pressure is equal to the height of the liquid column into density of the liquid into gravitational acceleration. What are the three factors here? Height of the liquid, density of the liquid, gravitational acceleration. Now, pressure is P, right? P is equal to, how to refer H? Height, H. Density, I told you take rho. Usually we are using D also, but here we are using rho. Into, what is gravity? G. So P is equal to H rho G. What is that? P is equal to H rho G. Height, density, gravity. What are the three? Height, density, gravity. All three are directly proportional with pressure. Okay. But the thing is, gravity cannot be changed unless you go for another planet. So gravity is same. But these two can be changed. And both of them are direct proportional. You increase the height, pressure increases. You increase the density, pressure increases. Okay. Density changing means liquid you have to change. So for the same liquid, you can't change. Otherwise, you have to add with some other solids or something. Okay. Something like that. Normal water and salt water. Why? Normal water, if it is 1000, salt water would be slightly more than 10. Because salt water contains solid salts. Solid salts are there. Okay. So P is equal to H rho G. What are the units? Tell me the units for height. Height is measured in meters. Yes. Centimeters, if it is given, you have to convert. How to convert centimeters into meters? Dividing by 100. Rho is measured in kilograms per cubic meter. kgm minus. G is given ms minus 2. So height in meter, rho in kgm minus 3, grams in ms minus 2. So the pressure will be Pascal. Straightly when you cut it off, or when you simplify, at last it is as a standard unit Pascal. as a standard unit. Yes. So H rho G, this formula we are using for liquid pressure. Solid pressure, F over A. Solid pressure you learn, F over A force over area, liquid pressure, H rho G. That's the difference. And there is a relationship also. Okay. So turn the page number 3. Page number 3. There's a text box given. Can you see? Note it down, please. Draw the diagram as well. Right. Right. So now look at this. I gave you time. So get back to the previous page, page number 2. Hydrostatic pressure. Below that, some notes are there. Right? That is what we are going to discuss. So how to read. Okay, look at this. Now there are some features. There are some characteristics for this liquid pressure. Okay, only one. So listen carefully. Liquid pressure when you take. Okay, unlike the solid pressure means if you apply the force towards a certain surface, in that direction only the force will be active. Only in that direction force will be active. None other direction that the force will be acting. So pressure won't be acting in all the directions. So what is the direction you are giving the force? That is the direction pressure will be. Right, pressure will be. But when you come for liquid, listen. MCQs, these are important. Correct and incorrect statements. When you come for a liquid, you see, a liquid is trapped. Let's say water is trapped inside a polythene bag. And you're going to make some pinholes. Here and there, you're going to make some pinholes. You can see water spouts out. Okay, water spouts out from all these pinholes. Okay, yeah, water jets will be there in all the pinholes. They are spouting out. They will be moving out in all the directions. Okay, that is not in one direction. So you can see in all the directions they are moving out. They are moving out. Right? So this shows you water pressure or liquid pressure acting in all the directions. Liquid pressure acting in all the directions. So water is ejected in all directions. So there is liquid pressure in all the possible directions. Is that clear? So somewhere you are making a pinhole here, from here also. And because of that pressure only water spouts out. Water spouts out. And when the water spouting out, when you keep your hand close by to all these, one by one, you can feel some places will be having a high speed, some places will be having a low speed. Okay, so that goes up with another point, right? So is this part clear? This part clear, right? Okay, so take a writing book, please. Take a writing book. Quickly draw this. Yeah, write this down. Quickly draw this. No, that's fine. It is there on the tube. That's fine. Go to your writing. You never read that, right? Take your writing. Take your writing and mark it down. No need of the hand to be drawn. Okay. Yeah, only the back, and you can mark it as a tying up something. You can tie it up, right? No need. Absolutely, you right. No need to draw the hand. Okay. Just show it is tied up. Using a rope or something, it is tied up like this. No need of a pencil for this man. No need of a pencil. Right. This much large. Some large. Hey guys, look at this. Here, boys, look here. Look here. All the spout should be coming down. It cannot be like this. Okay. So it cannot be like this unless you are giving a pressure towards. Imagine how you are taking a water. Is a water packet. Okay. Upward you are injecting, then it would be. Apart from that, this can't be going up. Okay. That's fine. Someone said, sir, the gravity is going up. At least you found it out, right? It cannot be. It cannot be. Okay. So don't go there. That's wrong. That is what I told you. That is what I told you. If you are ejecting it upward towards, then the pinhole through that it will be going up. Now here it is not like that way. We don't give an external force here. We are just holding it up. Gravity is down. Is that clear? Gravity is down. Yes. Fine. Look at the next point now. Look at this. Look here. So hope you can remember the previous diagram. Now here, you have a bottle or a test tube or the same like polythene bag or whatever it may be, right? Now we see what we do. We take the points, the pinholes at the same level. At the same level. Can you see the pinholes are taken on the same level? Okay. The pinholes are made at the same level, and when you observe, you can see water spouts out. Shazeen, listen. Water spouts out at the same rate, same speed. Water spouts out at the same speed, same rate. This is because of, we told you earlier, right? The height matters. Since all of them are having the same level, look here. Since all of them are having the same level, the pressure here will be equal because all of them are having the same height of water. Same height of water. All of them are having the same height of water. So, okay, since all of them are having the same height of water, guys, and the other thing is, look here. Okay, bottle is, we might have drawn like this, but it's having a 3D structure, right? When you're gonna make the pinholes, closer to the end only, you are taking the holes on the surface only. So on the surface only, you are going to take the pinholes. Clearly, all of them will be having the same height because here it is, identical. Here it is identical. Can you see? So whatever the direction you are changing, you are turning around, same identical surface is there. Otherwise, you can argue, sir, these 2 points when you are taking up to this level, what is there? But here, up to this level, what is there? That argument you can come up with. That is what I am telling. This point, these 2 points are not having water up to this level because these are also on the surface. All the pinholes are on the surface. So this point I am taking because here the water level is high. Here the water level is high. So to avoid that argument, what you do when you are drawing the diagram, take this as a cylindrical tube. Is that clear? Take it as a cylindrical tube and mark the water up to this, somewhere up here, on the same level, right level. Okay. So this is the water level you have to mark. Did you understand my point? Take the same water level so that you won't be mistaken with that idea. So now you see, since having the same water level, height of the water level above this point is same, right? Can you remember we wrote the definition? What was the definition? Pressure at a certain point in liquid. Pressure at a certain point in a liquid is the force applied by the liquid column above it. So above this point, this is the liquid column, right? Liquid column. By this liquid column, what is the force given? That is called the liquid pressure. So since all of them are having the same height on the same level of points, will be having the same pressure. Now let's say somewhere here, guys, somewhere here I'm going to mark some points. Since all of them are having the same height, will be having the same pressure, right? Same pressure. Did you understand that point? Is that point clear? Same level, horizontal level, not vertical level, not vertical, horizontal. Horizontally on the same level, when you're gonna concern the points, same level, any points you take will be having the same pressure, but the condition, upper part should be having a uniform, level of water. Uniform level of water. Did you understand that? Okay, right. So we'll note this down as well. Mark the spouts province. Mark the spouts. Mark the spouts of water properly. You have to show that they are having the same spout. And write that point on. Write the point. Earlier also should have written the point. Okay. What ejecting all the directions. Previous. What ejecting all. Top to bottom. Top to bottom. Above the point height. Above this point height. Okay. Mark is right. Write this point here. Pinholes of the same level eject water to equal distances. Okay? Yeah. I'm going to erase this. I'm going to erase this. Okay. Yes. I will get it ready. Look at the next point now. Look at this point. Right? Now can you see? Here also make sure. Right. When you draw this quickly. Okay. Now you do have 4 points. A, B, C, D. 4 points are there. Okay. Now you see, all these points are different levels, right? Different levels, right? And we take the height of the water, height of the liquid column, not the water bottle side. Okay, bottom to upward, not the water bottle side. We take the height of the liquid column above the point we concern. Above the point we concern. You understand that point? Right. Now, when you're gonna look at these points, above A, this is the only height of what? Let's say this is the level. Okay. This is the level of water, let's say. This is the height of water above the point A. Correct? Above the point A. And this is the height of water above the point B. So this is for height A. And this is for height B. Height B. And when you come here, this is the height of liquid above C. And this is the height above the point D. Right? So can you see? The height of the liquid columns are different. What is the orders? HA, HB, HC, HD. It's increasing, can you see? Increasing by HD. So earlier we learned when the height is changing, pressure changes. And it is directly proportional. Direct proportion means when you're gonna take the pressure at all these points, with the height, pressure should be increasing. So the pressure at these points increases in this. So the pressure you give it at A is less. So that water spouts slower. The speed of water coming out is less. And B is more, pressure is more, so the speed is bit more, so it goes bit more, right? And C is even more than that. So the speed at C is even more than that, so it goes furthermore, horizontally. And then D is the highest speed, because now don't misunderstand with the bottom length, okay? Not from the bottom we are taking, from the top, the water column. Okay, or else above the point, what is the water column's height? So you see now, at D having the highest distance, highest length, so the maximum height is there, maximum pressure will be there, so water spouts out faster. Can you see the distance is that clear? So this is the distance of A, distance of B, distance of C, distance of D. Horizontal distance is increasing as the pressure is high. Clear about that? Take the note, mark it down. Yes. Right. Fine. Now look at this. Look at now. Here. Now you see. Wise. If the height of the liquid column is same, okay. If the height of the liquid column is same, as far as the same height is there, no matter with the shape of the container. Whatever the shape of the container it is, it doesn't matter. Just imagine you are going to take it at the center here, through the center line. Okay. So you are going to take it center. Okay. So at all these A, B, C, D, E examples, you're gonna find out the pressure at this bottom. Let's say either here. These points you are going to find out. These points you are going to find out the pressure. Or else even here you are going to find out the pressure. Either the upper level or lower level. As far as all of them are having the same height, can you see? Height is h. Height is h. It is not A, B, C, D like height is changing. Same height. All of them are having the same height. If the height is same, and the liquid also same, right? Liquid also water, let's say water, same water, same liquid. Then the density will be also same. How do you find out the pressure? H rho d, right? Height is same. Right. Keep it there. Height is same. Density is same. Gravity is anyhow same, right? So H rho g product when you are taking, pressure will be same. So this is what we took in the second point. Can you remember? On the same level, as far as the height is same, on the same level, the pressure will be same. So no matter of the shape, you can say different shapes are there, irrespective of the shapes. So shapes will not affect the liquid pressure. Shape will not affect the liquid pressure, irrespective of the shape. If the height is same, pressure will be same. You understand that point? Okay. So we take this as pressure at A, pressure at B, pressure C, pressure simple letters are taken, right? D, pressure E. So what do we say? All of them are equal. Clear? So to do this experiment, you are using some PVC tubes cut into different shapes, and you are going to do it. Simply, shapes are what considered here. Okay. So on your tube, can you see there's a point in page number 2? Dependence of liquid pressure on the shape of the water column. This one, can you see that? Can you see? Here, there's a space here, right? Can you see there's a space? Mark. What's going on? There's a space given here. On this space, mark it as refer the writing book. Mark here, refer the writing book. I'm telling you page number 2. Page number 2, there's a space here, right? Can you see? Okay, there you write, refer the writing book. Okay, and take this to the writing book from page number 2. On your writing book, mark it as from page number 2 in tube. Okay, page number 2 tube. Right. From page number 2, draw this and mark it. Now here, you don't want to exactly take all the shapes because the shape doesn't matter here. So whatever the shape is possible, draw it. But properly mark the height. Okay. Right. And hurry up. Do it quickly. Make sure to bring your writing books, okay? Right? Bring your writing books. Don't come up with papers. Papers here and there you will keep. That's why I call you to keep a writing book. Okay? That is my friend. Anyhow, from the expression onwards, you definitely need the writing book, okay? I told you that I'm not giving you the joke. Yeah, whatever is given there on the board, the equal is 20, that is not needed. Same number of lines you take, then easy. Take the same number of lines on the exercise. One bench. This post. That right? No. If you are speaking, I have to take it as one. Right. Look at this example. Can I say here? Also the same weight, same height, same height. Height is not changed. So as the height is not changed here, same height will be having the same pressure. Will be having the same pressure. Right? So if the height is not changed, pressure will not be changed. Fine. Look at it now. Page number 3. Page number 3. Hurry up. Close it. Right. Below the textbook, text box. Below that text box, can you see there's a small line given? Right. What is the line given over there? Yes. The horizontal area of the bottom of a vessel with V is A and it contains N gram. So it's giving a long statement. What is the meaning of the statement? Look here. Look at this. We are having a tube. Okay. Look at this. The height of the tube given as h. The height of the tube is given as h. So, okay, listen. It's a sort of conversion. Listen. Height is h. And the surface area is A. Okay, here, what I did. Surface area is A. And the mass of the liquid here is M. Volume of the liquid is V. Okay. These are the data given. Density of the liquid is rho. What is the symbol? Rho. It is not P. Rho. Rho. So these are the points given in that statement. Okay. Height is h. Surface area, mass, volume, density, and the gravity is G. And gravity is down. Any other point given in the statement? Check it. If there are any other factors, no other factors, right? Right. Now, what are we going to do here? Look at this. We learned earlier P is equal to F over A, right? Can you remember solid pressure? Solid pressure is equal to force over area. I'm going to build up a formula or as the relationship between the combination or the connection of F over A and H rho G. Now, hold on, listen, don't disturb. Force over area we took for solids, right? H rho G we took for liquid pressure. Solid pressure, liquid pressure. So how to make the bridging between this is what we are going to learn. So I'm going to start it up with P equals F over A. And I have to end up with P equals H rho G. That is what the phenomenon means. Okay. I'm going to use some sub-formulas. Look at the way I'm going to do this. Okay. Look at this one. Now, the force is not given here right now. This is the point I'm going to find out the pressure. To find out the pressure at this point, I need the liquid column above that point. And this liquid column exerts a pressure by its weight. Okay. So the liquid pressure, the liquid column is there, it's having a mass and it will be having a weight. So, how to find out weight? Weight is equal to M into G. Weight is equal to M into G. So, on behalf of F, gravitational force is the weight. Mister, listen. Okay, gravitational force is the weight, right? Gravitational force is the weight. So, weight is equal to M into G. So, instead of F, on behalf of F, I'm writing M into G dividing by A. Correct? Did you see what I did? Instead of F is the weight here, weight is the force. So instead of W, I'm writing M into G. So can you see? I got G. So one by one, I'm going to take. Okay. Next, the mass is connected with some other formulas. That goes up with density. Density is equal to mass over volume. Density is equal to mass over volume. And what is the data I do have? I do have mass here. Then mass is equal to V into rho, right? V into rho. Correct? Rho means density. So when you take this V here, V rho is mass. So instead of this mass, I'm writing V rho. V rho into G dividing by A. What did I do? Instead of the mass M, I wrote V rho. So can you see rho is also obtained? Who is remaining now? H is remaining. The surface area is connected with the volume formula. Okay. When you are learning maths, under volume, different objects will be having different sort of formulas to find out the volume. But whatever, one common formula you are using. What is that common formula? No, length into breadth into height you are taking for the cube, right? And cuboid. Whatever the structures, even a cylinder, okay? Commonly, one formula you can use. What is that? No. 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 Surface area into height. Surface area into height. Okay, now whatever you know, everything you have written, right? You see, surface area into height. Is it? Let's say this is the cylinder. You want to find out? It's having a surface area, right? It's having a surface area. So this surface area you get it, and you are going to multiply by the height. It may be the height, or it may be the depth, or it may be the length, whatever. So surface area into that, how to multiply. So I'm going to take that V, volume. Volume is, sorry, surface area. Again, I'm going to connect it up. Right. Volume is equal to surface area into height. Volume is equal to surface area into height. A into H. Surface area into height. Whom I do have? I'm having B, right? Can you say I'm having B? So instead of this B, whom I'm writing? I'm writing H. Can you see? H. H into rho is remaining into G dividing by A. Can you see H is also there? And additionally, A and A, both of them are there, right? What I do? I can't do. So what is remaining now? H rho G is equal to. So this is how P equals H rho G was obtained. Okay? This is how P equals H rho G formula was obtained starting from P equals F. So this is the beginning. So three sub formulas we are using in between. Did you understand? Clear? Right? There's a space given on your tube, right? You have to separate it into three. Like this. Guys, look at this. Okay? Write them down. In page number 3. Page number 3, there's a space here. Quick, write it down, please. Hurry. Not now. What is this? This should be done on your tube, okay? On your tube. In page number 3. In page number 3, you have to do it. Yeah. How much we say with more names? Right, are you done? Every without any? Anyone else didn't get the papers? I mean, doing the papers didn't get. Everyone got it right? Get prepared for an online exam. This month, maybe this week. Okay. Be updated with your groups. Okay. Listen. Wait. Not to be hurry. Yeah, you have one more work to mark it. After this, let me finish up this lesson. After these 3 questions are there. Okay, can you see in the page number 3 and 4? 3 questions are there. Write them down at home. Using P equals HOG. Using P equals HOG. Conversions are there, properly converted. Properly converted. Is that clear? I want everyone to complete it at home and come here. Okay, guys. On few more months, few more days for your exams now. Get prepared. Always don't know. Having a certain exam, okay. So get prepared. Okay, get prepared accordingly. Fine. That's for the lesson. Listen now. All these days we were doing some papers, science papers and SQ papers I was giving you. Okay. Now, probably this week or next week you'll be having an online exam as well, but this week you keep the rest. Sundays. Okay. Get prepared for the all the lessons that you have done. MCQs will be started up. But don't think like since it is an online exam, we can copy and do it. Whatever you are doing, it's up to you. I'm not going to check it out. Right? If you have that iman, okay, that sort of iman, you want to be speaking like this. So don't show it. Don't cover your mistakes in the video. Okay, that's not good for you. Okay, right. Come back to the point. Now, be honest with yourself because you are the one who do the exam. Just showing me like some marks upon copy. Nothing works with me. You are the one who do the exams alone. That's clear? So do the online exams accordingly. And this month probably 3 lessons you are going to do. 15, 16, 17. You are having an extra session. In fact, extra session means your class day only. Your class day only. You will take in the morning works. Since it is a poetry. Probably maybe 70 or 30%. I announce you by this week or next. Listen, let me speak. Okay, 17 or 30%. So once I fix as 17 or 30%, don't tell me, sir, I have that class, this class, and I will get it up. Okay, either 17 or 30%, you will be having this class from the morning. Both of them are falling on Thursdays. Okay, so I'm taking that to increase the time to do some work. That is why 3 chapters covered this chapter. Okay. So there's a class, extra class for you all. Probably it is usually I have 2 hours, right? Another 2 hours will be added. That's all. Okay. 2 hours usually are in the class. With that 2 hours, another 2 hours lesson. So concerning the breaks and all, we will be confirming the time. Clear? So please join that class as well. Okay? Clear? That's what I'm saying. We will announce you. And moreover, get prepared for the exams, and I'm planning to do a sort of workshop. So along with that only it goes. Okay. So there's a high possibility that we'll be having it on the end of the month, 31st. A workshop along with the session we'll be having, and then a workshop back, and we are planning to do a small competition. Okay, for the class students. Competition. Okay, competition as a like an exhibition. Okay, projects to be done. Some sort of projects to be done. So what are you supposed to do? You are having a work to be done at home. That is, plan yourself. Okay, plan yourself with individual projects. Okay, individual projects. Group projects. Next week I'll speak about. Individual projects you plan. Make a proposal. Not to give for someone. Not to give for someone. Okay, understand? Adam, we will thinking about it, right? Right, listen. So make a proposal, a project proposal like this. Okay, I'm not giving any formats at the moment. You have to do it in your own search. You think what's the topic you are going to execute? You are going to make the project on which topic? You think about and make the project proposal. This is the topic. This is what the materials I need. This is how I'm going to complete it. Okay. The contents you are going to make. That proposal next week again. Next week you have to read. Yes, sort of A4 paper. 2 A4 papers you can use. In the first page you have to mark your name and all. Second page contains how you are going to do it. Okay. So I need this from everyone. An individual project to be done for the exhibition competition. Okay, you are going to exhibit, you are going to make it. Maybe any sort of any topics in science. Any topics in science, not any other subjects. In science, any topics you can take, how you are going to obtain those materials and how you are going to make it. I need the proposal. Okay, and you should be able to do it within 2 weeks time. You know why? So I thought you probably 31st you're gonna have. Okay, 17th or 31st. So since I'm going to make both of them at once, most probably 31st I might be having. That's it. Whatever your own project it should be to enhance your knowledge in science, to make it more interactive with the lessons that you are learning. Related to the lessons you can do. And next week once you are getting into that, I will go through and I will say what I am supposed to do, and I will instruct you how to do it. How to do it. And it will be happening as a competition. Okay. It will be happening as a competition. Okay. Yes. Competition as it goes, so that as a workshop completely on that complete day we are going to take it inshallah. Is that clear? Or next week, by next week time you will be getting announced. Chapter 1 is already done and you can do it. Okay, fine. Right? So you see, don't come up with those individual project proposals and all, right? When you are doing the individual project proposal, what is the lesson you are taking? What is the topic you are taking? Where from the diagram, like you can draw it or you can take it as paste it. Okay? Paste it. Is that clear? Clear about that? Fine. So, ending up this. See you on the next class. Good evening. Salam. Yes, slowly. One line is also happening.